you guys a set of questions to take a look at for homework. I will go through them. And then we will do our second last lesson of the course. I wanted you to classify the chemical reactions based on their equations. So here are the answers to the first 15 of those questions. Take a look, compare what you got with what I got, because you were supposed to have done them, and you had a tutorial block to do them in too today. And lots of you are in English, and what else are you going to do in English but science homework? Yep.
I was playing basketball.
Were your homework done? Well, so then you didn't need tutorial. But if your homework's not done and you were playing basketball, shame on you, I'm disappointed. Yes? Yeah, there should be an R there in number 7. That is a single replacement, you betcha. Was that the same thing you were going to ask? Okay. Yes, you and Ikpreet are correct. That should have been an R there as well. Okay. Comments, questions, concerns. Yes. I would love nothing more than to show you question 16. Okay, I'm going to flip the page. Going once, twice, thrice, sold. Okay. (17 through 30, there they are. Comments, questions, concerns. Let me know if you see any mistakes. Yes, sir. Wouldn't 25 be? Yes, you're totally right. It would be. 25 should be DR, not SR. You betcha. What about 26? It is not a double replacement because that is an acid and that is a base. So a neutralization reaction is just really a special type of double replacement. It's what's swapping spots if you look at number 26. The H and the Al are swapping. So you can think of neutralization as being a type of double replacement, but they're a special enough type that we give them their own name. So 26, I did not make a mistake on. Okay, so that's up to 30. Comments, questions, concerns. How do we feel about identifying reaction types? Okay, we feel good. Okay, then what I would like you to do, there's a whole bunch of pages in here. I am going to, guys, I want to show you a bunch of pages that I'm going to skip, that I'm going to save for you guys to use as chapter review. So I've got word equations and looking at reaction types. We're going to skip it. We're going to come back and use that as chapter review. I've got classifying chemical reactions. It's the same kind of stuff. And then I've got like sentence descriptions. We're going to skip that too. We're going to keep skipping. Skippity, skip, skip, skip. All the way to this page here. I would like you guys to slide down. We're going to go halfway down the page to this section where it says predicting products. Okay, so skip ahead till you find this page. Predicting products. This is the lab that you guys, basically what we're about to see here is the lab that we're going to do on Monday. I've got the lab booked for Monday. There will be 5 stations in the lab. 6? No, I decided I was going to do this lesson before we did the lab. So I gave up the lab. Mr. Easton's in the lab next block. We're going to do the lab on Monday. And you guys are going to need to work. This is a smaller group, so you guys should be able to get it all done in one block. So here we go. What we're going to do is today we're going to look at a couple examples on predicting products. And then I'm going to leave you with a bunch of stuff to practice. Basically what you're going to have to do here is I've got, what is there? There are 12 reactions there. And what you guys, to be able to predict products, you need to be able to identify first your, anyone who's on their phone, put it away, please. You need to be able to identify what the reaction is first before it makes sense to talk about products. So what we're going to have to do is, one, we are going to have to determine the reaction type from the reactants. Which we've already kind of done. All of the practice questions that I gave you for each of the reaction types only had the reactants, but I also told you what each type was already. You knew the single replacements for single replacements, and then you went ahead and found the products. Now what you're going to have to do is determine the reaction type from the products. Two, then what we're going to have to do is create the products. And this is what you're going to have to do in the lab that we're going to do on Monday. I'm going to have stations set up in the lab, and you're going to show up at the station, and you're going to have the reactants in front of you. You're going to need to predict what reactant or what products are going to show up. You're going to perform the reaction, and then based on your observations, it's going to tell you things about what appeared. So let's do a little bit of practice on this stuff. If you recall, I'll list them for you here. The 6 reaction types are synthesis, decomposition, single replacement, double replacement, neutralization, and combustion. We had specific types of reactants for some of these, almost all of these reaction types. Yes, sir? The pink is hard? Okay, so those are the words. And I'm not going to write them down, but what you need to start looking for are for each one of these, I gave you specific examples of the type of reactants you want to look for. For a synthesis reaction, what do you want to look for? Who remembers? What does a synthesis reaction do? They all create products. Creates what kind of product? Yeah, Vikram. 2 elements are going to combine to form one product. So let's look at this list. Oh, Himpar, you had a question? Okay. Looking at this list, there's 12 reactions here. Which reactions of these 12 combine individual elements together? Zn plus O2. That's zinc, that's oxygen. So this guy right here is going to be one of the synthesis reactions. And which other one? There's a second one. Mg plus N2. So these two, synthesis. These are the 2 reactions that are going to use individual elements to create what? Now we have to go make the product. What does a synthesis reaction create? Yeah, Himparis? Sorry? Not a synthesis reaction. Vikram? It's going to form a singular compound, okay? So what is the single compound that I could create using zinc and oxygen? It's going to be zinc oxide, and this is where we're going to have to go figure out what is the charge on zinc, what's the charge on oxygen, and now we have to build the compound. So you're telling me the charge on zinc is +2? Okay. Oxygen is -2. To do the work, I'll just toss the charges up there. So this thing is just going to be ZNO. When the charges are the same, you only need one of each. Cool. How about this one? What's the charge on magnesium? plus 2. What's the charge on nitrogen? -3. So we swap and drop. Yes, it's going to be Mg3 and 2. Very good. And there's nothing else on that list that is 2 singular elements. So those are all the synthesis ones. Yeah, Vikram. Yeah. Syntheses are done. Check. Decomposition. What does a decomposition reaction do? What kind of reactants does a decomposition reaction have? Sorry, Angel? Josiah? One breaks down to 2. It's the only reaction that only has one reactant. So look at the list. Which one only has one reactant? HGO and H2O. So these must be our decompositions. And when these things decompose, they just break whatever the one thing is down into the individual pieces. So HGO can only break down to what? Hg plus O2. Why is it O2? Yeah, because oxygen's diatomic. Cool. So then H2O is going to break down to? It's not going to be H plus O2. It's going to be H2 plus O2. Both of those guys are diatomic. It's going to create hydrogen gas and oxygen gas. Cool. And there's nothing else on the list that only uses one reactant. Which one do we want to go to next? We could do them in order. Single replacement. What does a single replacement reaction do? One swaps with a portion of a compound. Okay? So which ones do that? Which one has an element reacting with a compound? Louder, Malik. You were correct. Say it again. This next one. Is that the only one? And the one beneath it. And Malik's already said the next two are double replacements. You are correct, sir. I really should have done a better job of mixing them up, shouldn't I have? I'll retype it for next year. So then the iron in this first single replacement here, the iron is going to swap with what? It's going to swap with the Cu. So the Cu is going to come out, it's going to be alone, and now I need to combine the Fe with the Cl. Now, it's not obvious what the charge here is on the iron. We have no, honestly, we have no, without the names, we have no way of knowing. Because iron's multivalent, it's either going to be +2 or +3. Let's just use the +2 charge. If we use the +2 charge, then the formula is going to be what? FeCl2. If we use the +3 charge, it would have been? You bet. It's going to be one of those two products.
Can it be both?
That's a great question I don't know the answer to.
Let's say we go down the test.
If I gave you that kind of question on the test, you gave me either one, I'd give it to you. Next one. What is the aluminum going to swap with? Sorry? Ni. Ni is nickel. So the charge on aluminum is +3. So what's the formula going to be for the compound made up of aluminum and chlorine? And then the nickel's going to be on its own. Sweet. Malik's already said the next two are double replacements. Malik, you're correct. So what's going to happen here in this guy? I've got silver nitrate and magnesium chloride. Who's going to swap with whom? The Cl and the... So these guys are going to change places. So Ag and Cl are going to get together. And Mg and NO3 are going to get together. Have I built them properly? To build them properly, you need to make sure you use the charges. What's the charge on silver? Angel is 1. And chlorine's -1, so this guy's good. How about the Mg and the NO3? What's the charge on magnesium? It's 2. What's the charge on NO3? 1. So what do I have to do to this compound to make it correct? We're going to put a 2. We're going to put brackets around the NO3 and we're going to add a 2. Very good. The next one. What's going to swap? Someone said the Na is going to go with the Cl. So the Na and the aluminum are going to swap spots. So you're going to get aluminum with SO4. You're going to get sodium with chlorine. And now we have to build the thing properly. Angel, I heard you say something about brackets. So that means that can only go around the SO4. So what should the formula be for aluminum sulfate? What's the charge on aluminum? Aluminum's got a +3 charge. What does sulfate have? No. Phosphate is 3. Sulfate is -2. So then what is this formula going to look like? You swap them. Al2, SO4, 3. Good. And then Na and Cl. Na's got a charge of 1. Chlorine's got a charge of chlorine. Chlorine's also 1, -1. It's not alone. It's only diatomic if it's alone. So then you're done. Cool. Let's go. Well, let's do the next two. Where is the neutralizer that's single and double done? Neutralizations are, we've got 4 reactions left, and I haven't mixed them up, so. It's going to, well, what are the reactants? An acid and a base. So then the acids and the bases are these bottom two. H out front means an acid, OH out back is a base. So I've got an acid and a base, an acid and a base. And every time the first product for a neutralization is, the easy one is water. So I go H2O and H2O. Once the H's and the OH's have made their water, what's the second product of an acid-base neutralization going to be? The first one is going to have potassium and sulfate, but it's not going to be KSO4. It's going to be what? Potassium has a charge of 1. Sulfate has a charge of -2. So it's going to be K2SO4. And the second one's going to be NaNO3. Good. Because the charge on nitrate, the NO3, is -1. Charge on sodium is +1. So this is your neutralizations. And to find the combustions, we have to go all the way back up top. The combustions are the easiest one. They can be a little tricky to identify, I suppose, but the products are always very easy. Once you identify your combustions, and if you recall, your combustions were organic compounds, so compounds made up of carbon, hydrogen, sometimes oxygen, reacting with O2. It's all CO2 and H2O. That's all it is. Every combustion is the same. So those two are your combustions. And that's it. It's just an exercise in looking. Now, instead of giving you the whole equation, I'm only going to give you the left-hand side. You have to tell me what the reaction is, and then you have to tell me what the products should be. And this is what you're going to have to do in the lab on Monday. So, in order to practice this, here's what I want you to do. Flip the page. These ones are not in order. I am going to get you to take a look at all of these on this page. All of those bad boys. Yes? You betcha. And then I want you to flip the page twice. Go to this, find me this page here. Yeah. I don't want that one. I want this. I want you to jump ahead here to question number 2. Yeah. And this one has, instead of the equation, I give you like a sentence description of what's happening. And I want you to do these ones as well. All I want you to do is give me, instead of giving me a balanced equation, you don't have to do any balancing. I just want you to give me the skeleton for each one of those. Instead of balancing, give me the skeleton. I also want the type of reaction, and I want the word equation. It's the same stuff we've done before without the balancing, except this time now I've given you sentences. You need to tell me what you need to write out. I'll do it this way. The easiest way to do these kinds of questions is to start with the reaction type, do the skeleton equation, and then go back and give me the word equation. Sometimes maybe the skeleton equation is easier and then do the reaction type. My point being, the word equation is often going to be the easiest thing to do last. And there are L of those questions. So I want you to do A to L. You've got about a half hour left in the block, I think. Now you got 20 minutes left in the block, which should be which I think is plenty of time to do the bulk of these. That is what I want you to play with. If you need a hand, let me know. On your mark, get set, giver.